Good afternoon, Professor. I'm Monica Devala. I'm going to give the presentation about the article that I have selected, that is, which is the CipherFix, mitigating ciphertext side channel attacks in the software. So this project is mainly about reducing the attacks that were happening on the side channel, the ciphertext side channel software. So we hardly try to reduce the attacks which are happening in the ciphertext side channel. So now coming to the abstract of my project. So it mainly discusses the summary of my paper's objective, that which is to reduce the attacks that were happening on the ciphertext side channel, and it also discussed about the importance of the trusted execution environments. So what is the importance of having the trusted execution environments? So, in order to reduce the attacks that were happening on the ciphertext side channel, and it also gives the overview of the cipherfix solution. So, it gives overview about the cipherfix solution, which is used to reduce the attacks that were happening on the ciphertext side channel. So, coming to the introduction here, the introduction mainly discusses about the current trends in the data processing and cloud computing. So the on day-to-day changes in which are the day-to-day changes in the data processing and cloud computing. And it also discusses about the security concerns in shared physical hardware environments. So the main important aspects to provide the security, the main important measures that we should consider to provide the security in the shared physical hardware environments. So it also discusses about the role of PEEs in providing isolation and security. So it discusses about the role of PEEs in the TEs, which are the trusted execution environments, that which provides the data isolation and further provide the security. So that in further that avoiding the happening of attacks on the ciphertext side channel. So now coming to the next slide. Here my here the next slide discusses about the cipher leaks and ciphertext side channel. So here it mainly discusses about the cipher leaks. So how the ciphertext is going to leak, and how the ciphertext side channel is working, and how attacks are happening on the ciphertext side channel. Here it mainly discusses on the attacks. So why are the attacks are happening on the cipher leaks? So it mainly discusses about attacks, why the attacks are happening on the cipher leaks, and it discusses the risks that were associated with the deterministic memory encryption. So it mainly focuses on the risks that will occur when we encrypt the memory, and it addresses the ciphertext side channels is crucial. So it proposes that the ciphertext side channel very important. So coming to the next slide, my next slide was motivation and problem statement. So it opens a view on the motivation and the problem statement. So here the main problem was there should be some software based fix for avoiding the attacks that were happening on the ciphertext side channel. So it mainly focuses on the requirement for having a software based fix, and it it shows how the issues, what are the issues that were associated with the current hardware solutions and constant time code. And it mainly focuses on objectives of cipherfix. So what are the objectives? Why are we proposing the cipherfix? What does the cipherfix will do for the ciphertext side channel? So it discusses about all the objectives of the cipherfix. So totally the motivation and the problem statement discusses about why we are requiring the software based fix in a software, and the issues that are associated with the current hardware solutions and the constant time code, and why we are introducing the cipherfix. Why is the cipherfix is needed, and what are the objectives of the cipherfix? So coming to the next slide, which is the contributions. So here the contributions are dynamic taint analysis to identify memory areas that are susceptible. So here the dynamic taint analysis is the method which identifies where the memories are susceptible. That means where the memory areas where the attackers are gonna attack the ciphertext. So here the dynamic taint analysis is going to identify the memory areas which are going to attack by the attackers. Coming to the binary instrumentation. Binary instrumentation is here both the static and the dynamic for the mitigation. So here we have to for reducing. So here we have to reduce attacks on both the static and the dynamic memory. So coming to the binary instrumentation, it focuses on both the static and the dynamic memory. So coming to the next point, assessment and proof of concept execution. So it's going to assess and the proof of execution, how how the attackers are going to attack, and it's going to focus on the assessment and proof of concept execution. So coming to the next slide, it is the background. So what is happening in the background of the ciphertext? So it shows what's the actual work that is going in the background. So here in the cipherfix in my project, the cipherfix which reduces the attacks that are going to happen on the ciphertext side channel. It describes that AMD secured encrypted virtualization, AMD, which is a secured encrypted virtualization. In detail it describes about the AMD secured encrypted virtualization. So it is how is it going to protect the ciphertext in the ciphertext side channel. So it describes a detailed explanation of the AMD secured encrypted virtualization and information on encryption of deterministic memory. So in the background, it also how the deterministic memory, how the memory is mainly encrypted. So it's going to show all the information how the data is going to be encrypted, and an introduction to dynamic taint analysis and binary instrumentation. So here in the background, the main aspects that are going to take care, or like it's going to give an introduction to the dynamic taint analysis and the binary instrumentation in order to further in order to reduce the attacks that are going to happen on the ciphertext. So coming to the next slide, which is the attacker model. So now here the attacker model describes the primary principles. So an attacker how an attacker is capable of attacking the ciphertext that is in the ciphertext side channel. So it's my it gives the principles of the capability of the attacker, how the attacker is going to attack the ciphertext, and it gives the brief description about deterministic encryption weakness and their impact. So if there is any weakness in the encryption of the data, so how it's going to impact on the attackers. So if there is no any valid encryption, so it is very easy for the attackers to attack the ciphertext. So it mainly describes about the deterministic encryption weakness and their impact, an analysis of attack scenarios. So how the attack scenarios are going to happen when in different aspects of encryptions. If the information is strongly encrypted, it can reduce possibility of the attacks. So coming to the next slide, which is the main slide that mainly discusses the design of the cipherfix. So here the cipherfix is how the cipherfix is designed. So here high level design and components. Here the cipherfix design was mostly high level design and the components and the techniques for protecting memory rights. So in the design of the cipherfix, so it describes about how the cipher what is the design, how well the Cyberfix is designed. So it's here the design of the Cyberfix was a very high level design and the component high level components. Here we used different various techniques for protecting memory rights so that the attackers cannot attack the memory data. Here we introduced different techniques for protecting the memory rights. So in order to avoid the memory writes, we discussed various techniques and tracking data secrecy at runtime. So we can track the data, how well the data is maintained to track the data confidentiality at the runtime. So we provide different tracking data secrecy. So several techniques to track the data secrecy at runtime and different various techniques to protect the memory rights. And coming to the next slide, which is the masking techniques. So here coming to the masking techniques. So we are going to mask the data. So in order to make the task tough, in order to avoid the attackers to attack the data, we are gonna mask the data. So here in masking techniques, here we have the Cyberfix base, Cyberfix fast, and a Cyberfix enhanced. So in the masking technique, it's uh, in my project in the masking techniques it is explained detailed about the Cyberfix base, Cyberfix fast, and Cyberfix enhanced. And here we also provided the information for the methods that for updating mask and storing secret information. So in the masking techniques, we also provided various methods for updating masks. So data from time to time uh, to to change the masks, to change the structure of the masks, we provide several methods for updating masks and storing and maintaining the data very confidential, to store the data very secret, not to make the data available for the attackers to attack. We provided various methods to update for updating masks and storing the secret information. So coming to the next slide, which is the tool chain and implementation. We are coming to the tool chain and implementation. It is mainly focused on the steps in the Cyberfix framework, like the methods like the dynamic analysis and the structure analysis and static mitigation. So the main steps in the Cyberfix framework are like dynamic analysis, structure analysis, and static mitigation. The, their key components and their roles in the implementation. So in the tool chain and implementation, the tools mainly that were used for the Cyberfix. So to reduce the attacks on the Cybertech side channel, the steps in the Cyberfix framework are dynamic analysis, structure analysis, and the static mitigation. So these are the key components and what are their roles and how are they implemented. These are well explained in their implementation. Coming to the next slide, which is the evaluation and performance. Evaluating the performance, the techniques for assessing the performance. So we introduce various techniques and various type of several techniques that are used for assessing the performance, how the Cyberfix is performing its its duties. So we provide several techniques for assessing the performance and the runtime overhead for various versions of Cyberfix, and we also provide several techniques for evaluating the performance of runtime overhead for various versions of Cyberfix. So uh, however, there are gonna several versions of the Cyberfix. So in those various versions, we have the techniques that were involved to evaluate the performance of the runtime overhead in those different versions of the Cyberfix and elements influencing the influence of performance. So we also have the elements that which are mainly affecting the uh, performance. So we are going to assess the elements that are which influencing the performance in further increasing the performance of the Cyberfix. So coming to the next slide. evaluation of security. So how well this cyberfix is providing security for the ciphertext side channel attacks. So here we have several analysis of possible sources of information. Firstly, we will analyze how what are the possible sources of information leakage. So from where, what are the different sources that are serving the source for that are providing the chance uh, for a possibility of the information leakage. So we have to first analyze where the data is going to be leaked. So how the data is going to be leaked, and then the results of the collision detection and its consequences for the real world security. So here the results of the collision detection serves to provide the security in the real world, and its consequences for the real results of the collision detection and its consequences are serving the real world security. So comparing various PRNGs that are used to generate masks. So we are gonna compare the several various PRNGs that are used to generate masks, which is further going to provide the security for the ciphertext side channel attacks. So we are going to compare how various PRNGs are used to generate the masks, and in when we compare how different PRNGs are going to generate masks, then we can assess how strong which masks are providing more security than the other masks. So in further to provide better security for the ciphertext side channel. Discussion. Coming to the discussion slide, here we discuss the performance and security trade-offs. So how the ciphertext is going to perform, how well is its performance, and how well we have provided security. Ciphertext has provided security for the ciphertext side channel attacks. And here we are going to discuss about the practical factors to take into account while selecting PRNGs. So why the selecting the PRNGs is a crucial aspect where which can generate mask to the data. So here we have several practical factors to take into account while selecting PRNGs in Cyberfix versions. So which version is going to provide more security, which version is going to provide an effective mask for the ciphertext. So selecting PRNGs and Cyberfix versions are the most crucial part of selecting of providing the security and high performance. So future discussions for improving performance and accuracy. Here in the discussion, we had discussed about the future directions for improving the performance and accuracy. So in future, how we can provide more performance, how we can improve the performance, and how we can provide the how accurate our Cyberfix is going to work. So we discussed all these aspects in our discussion. So finally, coming to the conclusion, a summary of the significance of preventing side channel attacks on the ciphertext. So here we provided a summary. Why should we why should we prevent the side channel attacks on the ciphertext? So here we provided a summary. What is the need of preventing the side channel attacks on the ciphertext? And an overview of Cyberfix contributions and efficiency, final remarks and possibilities for more work. So how well we have provided the Cyberfix and how well we have designed the Cyberfix. We discussed about an overview of the Cyberfix. So how well the Cyberfix is going to work, and how well it's going to perform, and how well it's going to provide the security to the ciphertext side channel attacks. Why the why there is a need for why there is a need for preventing the side channel attacks that are happening on the ciphertext, and there is and we have provided an overview of the cipherfix contributions. So what are the main contributions that the cipherfix is going to provide, and how efficiently it is acting to avoid the possibilities of the attacks on the ciphertext side channel. So this is how we have provided in the cyberpix. So finally, thank you.